Hi, this is a second follow-up tutorial. Today we're going to talk about log-log plots. So usually when you plot relationships, they're a linear plot, yx equals kx, as you can see here. So what happens when the relationship we're trying to plot is not in that form? See, what's so great about this form is that we were just able to plot in Excel, fit our trend line, and then our slope of the line would be k. But if the relationship we're looking for is a power law, we can't get k from fitting linearly since there's an n term up here. So what do we do if this is the case? Well, what we can do is take the log of both sides. So if you take the log of this second equation, you get log of y equals log of kx to the n. From log laws, you know that extends to log y is equal to log of k plus log of x to the n. And then using the power law, let me scroll down. Using the power law, then you can pull down the n, and then this becomes n log x. So finally, rearranging the equation, we have log y is equal to n log x plus log k. So as you can see, if you plot the log of this versus the log of this, then this is effectively y equals mx plus b from that you should know from algebra, and n is our slope, and k is, log of k would be our y-intercept. And thus, by converting the equation that we get, so from our data points that we have, our x and our y's, we take the logs of both of them and plot them, then we're able to fit linearly to a power graph. So let's see a demonstration of this in Excel. So we're going to come over here to Excel. Here I have mass m and period t. This is our data. This is the a hypothetical experiment. This is testing how the period of an object oscillates at the end of the spring depending on the object's mass. Well, this relationship we know is a power law relationship, but let's, just for the sake of it, try to plot this. So you should know already from the previous video, very easy. Go to scatter, and I'm not going to bother with the axis labels, but so here you can see if I try to fit trend line that is linear, show equation on the chart, is not very good fit, because you can see that the points are kind of curving. So what do we do in this case? So I'm going to move this over here. So from the last tutorial video, you know we can calculate equations in Excel. So I'm going to type log. Excel has a lot of functions built in, so I definitely recommend that you look up what they are. For example, besides log, there's also sine, tan. You can even take the average of a range of numbers. But for the sake of this demonstration, we'll just use log. So I'm going to click log m will be log of the mass, and that's it. And I'm going to, like I said before, click this little black box, drag it down. And log t is equal to log of the period. And I'm going to click this here and drag this down. And now we're going to plot, once again, the mass is on the bottom versus the period. So go to insert, scatter. So we come back over here. Now we try to fit a linear trend line to this. As you can see, it is a much better fit. We display equation on the chart is about 0.4703. So this means that our n is about a half. And if you extend this to if you set intercept, so let's go back to format trend line, set intercept equals 0. Not set intercept equals 0. But if you extend this to the y-axis, which you can calculate using algebra by setting x equals 0, so we see that 0.807 would be the log of k. We can also calculate the k for this relationship. So as you can see, just by taking the log of both numbers and plotting the points, we can fit a much simpler line using Excel. So from this video, I hope you have realized the importance of the log graph and how powerful it is in helping us to solve cases where the relationship is not linear, where it's something kx to the nth power, y equals that. So y equals kx to the n, we're able to figure out from experiment, these are the points you're going to get from experiment. You can work backwards, and by plotting this line to the log of both y and x, so x, y and x, we're able to figure out what the k and n values are, even if we only have x and y. Okay, and that's it for this video. Thanks.